Welcome everyone, this is Vineet from Edureka. In today's session, we'll go through Apache Pig tutorial. Let's move on to the agenda of today's session, in which we'll start off with the entry of Apache Pig, in which we'll understand the necessity why Apache Pig came into the picture. We will compare the capabilities of Pig and MapReduce. Then we'll look into a case study of Twitter in which we'll understand how Apache Pig was used to solve the big data problem. We'll understand the architecture behind Apache Pig. Moving forward, we'll look into the components of Apache Pig. Then we'll understand data models and operators in Pig. Finally, we'll understand how to run Pig commands and Pig scripts. I hope everyone is very clear. Let's move on to the next slide, that is the MapReduce way. For writing a MapReduce code, one needs to have the programming knowledge of Java or Python to process the big data, right? However, the question that stands is, what if you are not from a programming background, right? So are the Hadoop days over for you? The answer is no, the Hadoop days are not over for you. Even apart from MapReduce, there are many other Hadoop ecosystem tools which doesn't require programming background, right? So in today's session, we are going to go through one such tool which is none other than Apache Pig. So what is Apache Pig? Apache Pig is a high-level data flow system which was developed by Yahoo. What Pig does is, Pig gives you a way using which you can write simple queries, and these queries are converted into MapReduce program by Apache Pig tool. This MapReduce is executed over the Hadoop cluster, and then the result is sent back to the client. This way you do not have to write the MapReduce program on your own. You are simply writing simple Pig queries that is written in Pig Latin. And as a result, what is happening is you are getting abstraction over MapReduce using Apache Pig. So just a fun fact for you guys. So approximately 10 lines of Pig Latin is equals to 200 lines of MapReduce code. So this is the difference. So if you have to perform a particular task in MapReduce, you are writing 200 lines, whereas the same task can be done in 10 lines or less than 10 lines. Okay. Basically, Pig has got two components. One is the Pig Latin language using which you can write simple queries, and second is the Pig execution, the execution engine which converts your Pig queries into Apache MapReduce. So let's move on and look into why do we have to go for Pig when MR is there. So there are two simple reasons. One is the Pig code is 1/20th of the lines of code that we have to write in MapReduce. So it makes your life very easy. Also, as a result of this, the development time also gets reduced, which is almost 1/16th of the development time required in MapReduce. So these are the two main reasons because of which we should always go for Pig whenever a task can be achieved using any of these tools. Moving on, let's understand and compare the capabilities of both of these tools, that is Apache Pig versus MapReduce. Apache Pig is a high-level data flow tool. However, Hadoop MapReduce is a low-level data processing paradigm, right? So you have to code in the basic programming language. Second point explains that. So in Apache Pig, you need not write complex programs. It can be done using simple Pig Latin queries. However, in MapReduce, you need to write programs using codes like Java and Python, right? The next point in Pig is you have built-in support for data operations or the database operations like joins, filters, ordering, etc. Whereas in Hadoop MapReduce, if you have to perform these operations, you will have to write the logic on your own from the very scratch, and hence it is a very humongous task. When we come back to Apache Pig gives you a high level data models as well, that is tuples, bags, maps. However, in Hadoop MapReduce, only the primitive data types are available like int writable or long writable and so on. There are no high level data types that are available or nested data types. Now let's look into some more reasons or advantages with Apache Pig. The very first point is, that is, Apache Pig can consume any kind of data that could be structured data, semi-structured data, or unstructured data. So you don't have to worry about what kind of data it is. It can be dumped into, it can be ingested into Apache Pig, and you can process that data using this tool. Okay. So second point is it has a data flow language which makes it easy for you to write queries in Apache Pig and execute the same task in very simple steps. Okay, reading and writing Apache Pig queries is very easy. Also, the steps that you write in Apache Pig is nothing but a series of steps like you load a data from a particular path, Second could be you filter the data on the basis of a condition, and then finally you dump the data on the screen or on the HDFS file system. These will be three different steps and they'll be executed in the same order. Finally, Apache Pig gives you a way of writing UDF, that is user defined functions written in any of the programming languages like Java or Python, and these UDFs can be executed within the Pig script itself. Now we'll go through the Twitter case study. In today's time, we have got such big social media giants, and one of them is Twitter. There are a lot of people that are there on Twitter which are sharing stuff on a day-to-day basis, and that way the big data that is generating at Twitter is increasing at a very fast pace. So it becomes very important for Twitter to process this big data and extract insights so that they can improve the offering that they are giving to their users and increase their user base. So let's move on and let's see how Twitter used Apache Pig to do that. But before, we need to understand the problems that Twitter had. So very first thing is Twitter's data was growing at a very fast pace, almost at 10 TB per day. This is an old reading. However, if you are able to find out today's rate, it would be much more than this. So it became important for Twitter to analyze this data and get insights out of it. And hence Twitter decided to move the archived data into Hadoop distributed file system. Okay, they started using Hadoop, they dumped this data to HDFS, and now they wanted to analyze this data and extract multiple insights on a daily, weekly or monthly basis, right? Now in this session, we are going to talk about one of those insights that Twitter wanted out of big data, and that was analyzing how many tweets are stored per user. Now why this insight was important? It was because later on they may target to increase their user base and want to get prepared. So using this kind of insight, they can always plan and scale up their infrastructure so that they are able to handle the larger user base that they are targeting. So now let's move on and understand the high-level implementation of the architecture they implemented using Hadoop HDFS and Apache Pig. So at Twitter, they had a database in which there were many tables in which the archived data was stored. So the insight that we want to extract is related to two particular tables, that is tweet table and the user table. Okay, so we'll be discussing that. So the very first step is to move these two tables or the data of these two tables into HDFS. Once the data is moved to HDFS, this data is loaded into Pig, and finally the data is processed by Pig and the result is stored back to HDFS. So this was the high level implementation. In the next slide, we'll understand the detailed implementation of the data that is flowing and how Pig processed it. So this is the detailed implementation as you can see on the screen. So let's start from the database, that is Twitter database, which had two tables, user table and tweet table. The user table had the details of all the users along with their user ID. So for example, user ID 1 was Jay, user ID 2 is Alec, and user ID 3 is Sam, right? When we come to the Twitter table, it had details of all the tweets that were posted on Twitter. For example, XYZ tweet was posted by user ID 1. Similarly, ABC tweet was posted by user ID 2, right? So the very first step was to import the data present in these two tables onto the HDFS, okay? And this can be easily done using tools like Scoop. Let me tell you that Scoop is a tool using which one can move data from RDBMS to HDFS and from HDFS to RDBMS very easily. The data was imported to HDFS using tools like Scoop. So once the data was moved, it was stored as flat files in HDFS. Now, once the data was moved to HDFS, the next step was to move the data or load the data into Apache Pig. Okay, once the data was loaded, it was in the exact same format and there were two relations created. One is user table and second is tweet table. Now the third step is after loading the data into Apache Pig, what we are doing here is we are joining plus grouping the tables, okay, on the basis of user ID, and this is called co-group in Pig. So after the third step, this is what you receive as a result. So in the third step, we actually co-group the two tables, okay. If you divide co-group, the first operation that gets executed is the join operation on the two tables, and on the result, a group operation is executed over the ID, okay. So once the tables are joined, this is the result that you receive 1JXYZ, 1JPQR, and so on. So that is, you get all the columns in one table itself. Once we have this, we can now group the table on the basis of the IDs. So for one, we have got three different rows that we have: one JXYZ, one JPQR, and one JLMN. For two, we have two different rows, and for three, we have one row, right? So once we have this, the next step is count the number of inner bags or the number of rows for a particular ID. So if you see the result, we have 3 count for 1, right? Because 1 had 3 different rows or 3 different inner bags. Similarly, 2 had 2 rows right here, and 3 had 1 row, and that is why it is 3, 1. Now after this, it was very easy. Again, there was a join that was done with the user table right here, which had the name of the user, so that the data made more sense. So what we simply did was, on the basis of ID, we joined this data with the user table, and the result was right here, 1J3, and similarly for other IDs as well. This result was stored back to the HDFS now. So once the result is there on the HDFS, it can be now pulled back into an RDBMS or the Twitter database, and it can be used in an existing system to view the result. Let's move on to the next slide, which is nothing but the animated representation of the exact same flow that we saw right now, which will give you a better perspective. So the very first step is user table and tweet table is moved to HDFS. Then it is joined and grouped by Pig. The data is sorted and aggregated, finally filtered to get the count of tweets per user, and the result is dumped back to HDFS. Apache Pig architecture. So the architecture of Apache Pig is very simple to understand. You have Pig Latin scripts, okay, that you can write for executing your queries over the big data. These scripts can be executed through grunt shell, which is nothing but the native shell provided by Apache Pig to execute the Pig queries. You can also submit a Pig Latin script through a Java client to the Pig server and execute over Apache Pig. Now once the Pig Latin script is submitted to the Apache Pig, it is parsed by the parser, it is optimized by the optimizer, and the compiler compiles and converts the Pig Latin scripts into Apache MapReduce code, and it is executed using the execution engine over the Hadoop cluster. So this is the simple architecture of Apache Pig. Also, I would like to tell you that this entire thing is commonly known as Pig MapReduce engine as well, because the entire thing helps in converting the Pig Latin script into MapReduce and then executing it over the Hadoop cluster. Now it's time we explore the components in Apache Pig. So majorly there are two main components which we saw in the starting slide as well. One is the Pig Latin. So Pig Latin is a very simple data flow language given by Apache Pig so that you can write the operations, transformations, or any analysis that you would like to do over the input data set. Okay. And finally the result is given back to you. What is Pig execution? Pig execution is nothing but the different ways using which you can submit your queries onto the Apache Pig. First, you can execute the Pig queries using a Pig script which has an extension of .pig. So all you need to do is create a file with a .pig extension, put all your queries within that, and execute it over Apache Pig. Second is the grunt shell, in which you get into the grunt shell and execute the queries one after the other. And the third is the embedded Pig execution, in which you can provision a Pig script within a Java client application and execute it over the Pig server. So these are the two main components of Apache Pig, and we come to Apache Pig running modes. Okay, Apache Pig basically runs in two different modes. One is the MapReduce mode and second is the local mode. First, we'll discuss the MapReduce mode. In this, we are using Apache Pig over the Hadoop cluster. Or in other words, I can say that you want to execute the Pig queries over the big data stored in Hadoop distributed file system. In this, the input data as well as the output data will be stored on HDFS. For executing Pig queries in MapReduce mode, you simply have to use the command pig. Okay, just have to write pig on the terminal and press enter. Similarly, if you want to use Pig in local mode, that is, you want to use Pig to process the data that is present in one file system or a centralized file system, in that case you can use the command that is called pig-x local. In this, the input as well as the output will be present as a single file in one file system itself. So why not I show you how to get into the Pig MapReduce mode as well as Pig local mode. Okay, so let me just go to the Edureka VM now. Okay, we have our terminal. I have the Pig setup already there. So I'll just show you the path that I've already set for Pig. So it is right here. So my pig is installed right here. So now I'll first show you how to use pig in MapReduce mode. As we learned, we just have to execute the command pig and press enter. So just look at the logs that will come on the screen. As you can see right here, they have picked MapReduce as the execution type, correct? So this is how you get to know that, okay, yes, it is using MapReduce mode. And we are there in the grunt shell, correct? So I'll just quit from here, clear the screen. Now I'll show you how to execute pig in local mode. So command is pig-x local and enter. So as you can see, pig local as the execution type, right? Because we mentioned that we want to execute pig in the local mode and we are there in the grunt shell. I'll quit from here. Okay, let's go back to the presentation now. Before going to the practicals of executing the pig script, let us understand the data models in pig. Okay, so there are basically four major data models in pig. One is atom, the other is tuple, the third one is bag, and the fourth one is map. We'll understand each one of them one by one. First we'll understand what is a tuple and what is a bag. Okay, because these two are used generally together. So what is a tuple? Tuple is nothing but an ordered set of fields, okay, which can contain different types of data. As you can see right here, there are four fields. So one Linkin Park 7 and California could be one tuple. Two Metallica 8 Los Angeles could be another tuple, and three Megadeth 5 Los Angeles again could be the third tuple, right? So these rows in itself is a tuple. To represent a tuple, you have to put them within the parenthesis. So the opening parenthesis is the start of the tuple and the closing parenthesis is the end of the tuple. Okay. The next is a bag. A bag is nothing but a collection of tuples. Okay. It could be one tuple, two tuple, or it could be multiple of tuples. It could be an entire row or a subset of rows. Okay. So let's look into the example. First of all, a bag is represented by curly braces. As you can see right here, this is the opening curly brace which represents the start of the bag, and there's an ending curly brace which represents the end of the bag. Within this you can see there are multiple set of parentheses which are nothing but tuples. Okay, as you can see, the first tuple is Linkin Park 7 California. Okay, only three fields. Second is Metallica 8, just the two fields. And third is Megadeth Los Angeles, that is these two fields, right? So what we are trying to show is a tuple within the bag could be a set of fields or it could be the entire row. Let's move on to the next slide now and understand what is a map and an atom. Okay. First of all, we'll understand map. A map is nothing but a set of key value pairs. Okay, just like any other programming language. So right here, the text before the hash is nothing but the keys. So band is a key, member is a key, origin is a key. Similarly, the text after the hash is nothing but the values. So Megadeth is a value, 8 is a value, and Los Angeles is a value, right? So in Pig, hash is the delimiter that represents the difference between key value pair. So the value left to the hash is the key and the value right to the hash is the value. So every row is nothing but a map which has a set of key value pairs. However, a map cannot contain duplicate keys. As you can see, this map has only got band, member and origin. Okay, there cannot be another key with the name origin or member or band. Similarly with the second row and the third row. So to represent a map, you need to use the square brackets right here. So this opening square bracket represents it is the opening of the map, and right here is the closing of the map. The next is atom. Atom is nothing but the basic data types that are there in most of the languages like int, float, long, tuple, char. Okay. So these are called atoms in Pig. Okay. So there is nothing much to understand in atoms, and it's time we move on to the next slide and we look at some Pig operators. Okay. So there are multiple types of Pig operators. However, we have listed the most commonly used Pig operators, which is nothing but the relational Pig operators. Okay. For example, you have got load. Load is an operator to load the data from the local file system or HDFS storage into Pig. For each is another relational operator that is present in Pig which generates data transformation based on columns of data. So just don't get confused. What happens is for each row, for each generates a set of columns that has been specified in the query. We are going to see it as well as in practical today, so you'll get clear from there. Okay. Filter is as simple as filtering the relation on the basis of a condition. Join is to join two tables or relations on the basis of a column. Order by is to sort a relation or values on the basis of one or more fields. Okay. Store is another relational operator used to store the data onto the HDFS or the local file system. Distinct is nothing but to remove the duplicates from the set of rows. Group is to group the data on the basis of a particular field. Co-group is nothing but a join operation between two relations followed by a group operation based on a field, right? So this is what Twitter used, which we saw in the example before. So let's move on to the next slide, and it's time for some practicals. Okay, we'll go into the grunt shell and we'll execute few commands over a sample data set. First of all, let me show you the sample data set. So as you can see, this is the sample data set we are going to use to execute certain queries on this data. Okay, the first column is the employee ID, the second is the name of the employee, the third is the department he's in, and finally the location from where he belongs to. So guys, we can use this data set from the local mode or from the MapReduce mode. So the objective here is to understand the MapReduce mode in depth. Now let's go back to the terminal and move this data to HDFS. So the command is hadoop dfs -put. I'll give the path to the input data set that is present on desktop, datasets and input. I'll move it to the root directory of HDFS and name it as pig input and enter. Okay, looks like the file has been moved to HDFS. We'll quickly check. Hadoop dfs -cat /pig input. Okay, so this is exactly the data that we moved on to the HDFS. So guys, we want to execute pig in MapReduce mode. So what is the command I should execute? It is simply pig. As you can see, it has picked up the MapReduce execution type. Okay, we are in the grunt shell now. So the very first step that we need to execute is load the data from HDFS into Apache Pig relation, right? So this is the command using which we can load the data. Employee is the name of the relation, and we are using the load operator to load the data from Hadoop HDFS, and the name of the input file is /pig input. We are using the pig storage, which is a storage type in pig. Now we are mentioning the delimiter of the file, that is comma. We are mentioning the name of the columns along with the data types that is there in the input file. So the first column is SSN, which is nothing but the customer ID, which is of type char array. Next is the name, which is again of char array. The third was department, which is again of type char array, and the fourth is the city they belong to, and again it is of char array. So I'll just execute this command. Great, so the data has been loaded into the relation that is called employee. We'll just dump this relation. Okay, let's see the result. So dump is another relational operator using which you can dump the result onto the screen itself. Just look at this. So as you can see, the input data that we have loaded into the relation has been dumped on the screen, right? So it's time that we execute our next step. So now let's use the for each operator to find out the name and the department of every employee. Okay. So this is the command that we need to execute. So we are naming the relation as emp for each. For each is the operator that we are using from the relation employee that we defined before, right? And we are generating the name and department for each row. So guys, what we are doing is we are selecting only two columns, that is name and department, from every row. I'll execute the script. So the relation has been created and it's time we dump the relation, right? So this is the result. Okay, you have the name and the department they have worked in. So John worked in sales, Alex worked in marketing, Philip worked in operation, Terry works in sales, Jesse worked in development, right? Now let's try and find out how many employees belongs to Austin. Okay, and in this case we'll have to use an operator that is called filter, correct? So this is the query that we need to execute. So we have a relation emp filter equals to, filter is the operator on the relation employee that we created in the starting, by city equals to Austin, right? Very simple to understand. I'll press enter. Now we'll dump the relation, that is dump emp underscore filter. So we have the result. We have only one person from Austin, right? Now let's order the employee on the basis of their social security number. Okay, so we have the relation that is emp underscore order. Let me tell you that the name of the relation could be anything. However, you should always put a meaningful relation name, okay, so that you can easily identify this relation belongs to which operation, okay. Then we'll use the operator order. We'll use the relation employee that we created in the starting on the basis of SSN in descending order, okay. I'll press enter. Now we'll dump this relation, that is emp underscore order. So this is the result, as you can see. If you notice, the records are present in the descending order of social security number, right? 5555, 444, 333, 222 and 111. Correct? So this is how you use the order operator. Now let me tell you how to use the store command in Pig. So let us store the emp filter relation into HDFS. So the command would be store operator, then the relation into, and the name of the file in which you would like to store the data on HDFS. Okay, I'll press enter. So guys, looks like the file has been created on the HDFS. Let's go and check. This is the name node health UI. I'll go to browse the file system. Now let's look for the directory pig result that we created. It's right here. We'll open it and we have the part file present here, right? I'll simply download it. I'll save the file and let's open it. As you can see, this is the record that got stored on HDFS. It is because if you remember, we stored the relation that is emp underscore filter, in which we were filtering all the records on the basis of city equals to Austin, and hence there was only one record which is stored, right? Let's move on to the next slide. Now we'll see how to analyze logs using Apache Pig. Okay, so this is the log file that you have. This log file has been created by an application which processes the sample class recordings. Okay, so this log file is generated when the application is running and it records various events into the log file. So the task is to understand what are the various events that are recorded in the log file as well as the frequency of these events. Guys, first of all, let me show you the sample log file that we have. So as you can see, this is the log file. So these are the events that we are concerned about. Okay, this is what we want to extract as well as the count of these events. Okay, so info, fatal, debug, warn, trace, errors, and so on. So let's get back to the terminal now. Now in order to execute this task, I've created a pig script. So I'll just quickly show you that pig script now. So guys, this is the pig script that I've written to extract the details out of the sample log file. Okay, as you can see, it has a .pig extension, right? We'll be understanding each of the queries present in the script one by one. However, let me just quickly execute it for you and get the result. Okay, so for that what I need to do is I need to write pig, that is I want to execute the script in pig MapReduce mode, right? And then again I need to mention the path of the pig script. Since my pig script is present on my desktop, I will give the path to my script, that is desktop sample log.pig, right? And I'll press enter. So guys, this is the result that we have received. These are the list of all the events that were there along with their frequency, right? Trace is one event which came 816 times in the log file. Debug came 434 times, info for 96 times, warn came 11 times, error came 6 times, and fatal came twice. Okay, so this is the final result in the descending order of their frequency. Now it's time that we go to the pig script and see each and every command and understand it. Okay, so this is the pig script that we have. The very first command that got executed was log equals to load sample.log. Okay, we are creating a relation log in which we are storing the sample file. Here we are not defining any schema, hence the entire row will be there in one single column and can be accessed using $0. Okay. In the second query, what we are doing is we are creating a relation levels in which we are trying to extract the events that are present in a particular row. For that, what we are doing is for each row, we are extracting the regex that is there, which is matching either one of them, that is trace, debug, info, warn, error, or fatal. Okay, it is getting stored under log level. So once this relation is executed, next is to filter out the records which are not null. Okay, that means we are trying to remove the records which has null values, because there were certain rows in which there were no events mentioned, and in that case the value would be space, right? It would be null, and hence in that case what we want to do is we would like to only keep the records which are not null, and hence we are executing the query filter levels by log level and is not null. Okay. Okay, so once we have all the records which are not null, the next step is to group them on the basis of events, because the ultimate thing that we would like to find out is the frequency of each event, correct? So as you remember, in the second query we were storing all the events as log level, correct? So in this query what we are doing is we are creating a relation grouped levels, and we are using the operator that is group, and we are grouping all the log levels that are present in filtered levels, right? Once we have all the records grouped by on the basis of events or log level, the next is to find out the frequency by summing up the values that are present for each event, right? Which we are doing using the function count, in which we are finding out the list of records that are present for each event, correct? So once we have all the counts for each events, we are sorting the events on the basis of their count in descending order, and the result is stored in the relation result itself. Finally, we are dumping the result on the screen, correct? So this is the process or the queries that are required to find out the events that were present in the log file along with the frequencies of their occurrence. So we'll get back to the presentation now. So we are done with this slide. We'll come on to the next. We've already executed the pig script and analyzed the log. And finally, we come to the end of this session. Thank you guys. Have a nice day.